I
Perfect.
don't know if I'm going to get it any better. Like the countdown, it jumped to 3 really quick. I was, oh, I'm going to miss it.
No, you did it. You nailed it. Wow. That was probably the
It
most
happened.
perfect intro we've had ever.
It's
At
pretty
least since
awesome.
Stephanie.
Yeah. When we were under official management, yes.
Yes, when we had a professional helping us. We were anyway, whatever. We miss you, Stephanie. Um Hello, GitOpsians. Welcome back to another episode of GitOps Guide to the Galaxy. I missed the last one. Fun fact, old cars break down, and my car is 18 years old, and it broke down, and I got stuck in the middle of, I got stuck on the beautiful central coast of California at my older sister's house, who I hardly ever get to see. It was terrible. I had to go to the beach and out to dinner. God, like, but I also didn't have any ability to like join the stream that I had actually specifically set up for my own benefit. So I still have to go back and watch the stream we had 2 weeks ago with Christian Hernandez. But that was where I was on the beach. Sorry, not sorry. Yeah, so we're back today. Quick double checking if we have announcements. I don't think we have announcements.
I don't think so either.
Amazing. I love not having announcements. Okay, so skipping straight from the announcements, I get to introduce our guest. And I normally let our guests introduce themselves, but I'm going to introduce Simon a little bit because Simon will be too modest if I let him introduce himself. So joining us today is Simon. Simon is on my team on Azure Red Hat OpenShift. Simon is one of the, like, every time we're like, oh man, we need a dashboard, or oh man, we need to observe this, or oh, what if we had like this data point? Like Simon will come back around in like 5 minutes, like lickety split. He's like, here's the dashboard we needed. Oh, we didn't really have metrics for it, but I was able to daisy chain this other thing together to understand, and get an approximation until we release a more proper like code change with the metric. By the way, here's that too. Like, I've never met anybody who can put together a solid observability dashboard and then present it at the executive level the way Simon can. So now that I have bragged on him a little bit, I will let him introduce himself a little bit more. And then he will, I'll go ahead and let you transition just straight into our topic on critical user journeys, because I know that you have a lot to get through today.
Yeah, well, thanks for those kind words, Hill. I definitely appreciate that, and that's very nice of you. So yeah, as Hill said, I'm a senior SRE here on Arrow, and I've been in operations for quite some time now, and for a period of my time at Red Hat, which is about 5 years, I was a regional lead. And kind of what that was is that it's basically an operational escalation. And people would come to me for all sorts of problems. I would be in PMRs or RCAs. I'd kind of deal with anything related to operations. And that really kind of set the ground for me to be very customer centric and very customer focused. And like Hill mentioned as well, is that, big data. I like working with metrics and observability. And I like making kind of agnostic, non-biased decisions based off of that.
And you write Kusto queries faster than anybody I've ever met.
Yeah, definitely. Well, Kusto is pretty awesome. It's a very cool tool. It's really interesting to use, and it's really powerful too. So I've just worked with data for a large amount of my time here at Red Hat, and kind of these two different like concepts bled together. And being customer focused and big data and observability really naturally led me into user journeys, and that's kind of the concepts that I want to go over a little bit today. And so I'm excited.
All right, let's do it. Do you want me to? I know you have slides. Do you want me to bring your screen up?
Yeah, we could bring it up for this if we want. Yeah, I have quite a bit of material to cover today, so hopefully we get to all of it. If not, that's totally fine too. Maybe we'll upload the slides or something like that and go from there. But the first part of this is I really want to get us into like thinking in a different perspective. and a different way than maybe we traditionally have in the past. So I was actually working with, I was kind of running over a few things with AI last night, and it came up with this sentence. So this is from Soul. And I asked what its name was, and it said that's what its name, because it was ChatGPT 5.6 using the Soul model. So, anyways, um, this is a good way to kind of represent user journeys. So, if we do not measure whether customers achieve their goals, how can we know our service delivers value? And as we think about that a little bit more, and maybe think about like a service that you operate, what customer goals does that service support? And if you think about like how are you measuring those goals? How are you measuring and prove that those goals were achieved? Right? Like what's our measuring stack right now? So if you're thinking like, I measure on CPU and pod health and cluster operators and those types of things, you're only actually measuring the machinery, and you're not necessarily measuring the customer goals and the outcomes. And that's what user journeys do. They connect the two. So they connect the measuring from the machinery and also the customer goals. Next thing is like, what is a user journey? So it's a pretty simple concept. A user journey is how a user achieves a goal, and it's capturing basically the end-to-end experience a user has while interacting with the service to achieve that goal. So just at like a high level, some user journeys are like installing a cluster, creating a node pool, configuring external auth, connecting to a cluster, like deploying workloads. These journeys represent customer outcomes, and this is the thing that a customer kind of values, and this is what they're paying for, right? They are trying to meet their objectives by deploying an application and something like that. So this directly represents their goals. So maybe breaking this down a little bit further. So a user journey, when we look at this, like who's the users? So in the example there, it's a customer at Unicorn Company, right? But users could also be SREs. So SREs could have their own goals. Maybe you want to measure like the metric stack that you're using, maybe Prometheus, and you want to know if you're sending metrics, because if you're not, then you don't know if your service is up or not. Maybe you want to measure your logging stack.
This is my favorite conundrum, by the way, in our world. How do you observe your observability, right? That chicken and egg problem is so fun.
Exactly. Yeah, we just spun one up on that as well. So, diving into those details on what that looks like and planning that goal essentially for what SRE is aiming for. Product managers as well can kind of use this. So product managers, can a customer create a server or a cluster? Can they, install external auth? These are kind of features that product managers sell to customers and what customers pay for to meet their goals, right? So product managers could kind of have their own user journey. So it applies to, various people. I had a thought too of like, can AI have its own user journey or like automation? And, can maybe thinking about that as like having a AI bot on like a systemd service on some service, and going through like, am I healthy or am I not healthy? Or maybe having automation, maybe your CI, maybe that's part of your user journey, right? Is that, can automation install a cluster? Can it scale node pools? Can it do those types of things? So it's all really, goals and outcomes, and that's what we're trying to focus on here. And yeah, what is a goal? So they define the outcome they value. Okay, sure. So yeah, goals are basically outcomes and something that a customer is trying to achieve, or some kind of user.
Yeah, way back in the day, because as you probably recall, I started my career in quality engineering we used to call these the golden paths, right? What is the golden path, right? And so the golden path would often be your smoke test. To be like, okay, I can log into the application, I can add something to my cart, and I can check out and make a purchase, right? That's the golden path for like all e-commerce, right? That is one golden path.
Yeah.
But critical user journey, and certainly in our more complex system than that, it really expands that golden path a little bit more, because at every step, right, we're not just defining what is the goal, but it's also like, what is the expectation that we have around that goal? So like, if it's like, oh, I can log in, it's like, and also the login doesn't take a very long time, or it doesn't require, like, if I have to do a dual factor authentication, like that text message actually arrives, as opposed to me having to resend it to myself 5 times, give up, and then try again the next day, which happens way more than I'm comfortable with. Not on our stuff, but in like, you know, things that I'm trying to use. We don't do text message dual factor authentication, just for the record. In case anybody was wondering, it's not us. Right. And so it's like, but yeah, you have it there. That what happens along the way, right, is what are our expectations as we're walking down this path. And I think that, to me, is like, that's what really takes it from that initial golden path testing, smoke testing, etc., that we had in quality, and that's the differentiating factor between that and like critical user journeys for reliability. And of course, critical user journeys are not only for reliability, they're for product planning, and you mentioned it, right? There's lots of things that, you know, but when we put that reliability lens on it, like that to me is what are our expectations at each point in time. That's where we as reliability engineers start really getting to leverage the power of them.
So do you guys, at your level, right, like when you're, so let's just take the customer out of this for a second, right? Like when you guys are like, hey, this feature would be awesome. Do you use this same formula where you come up with a user story and kind of, you know, you go through like the whole build it out, like here's the feature that I think we should build, and here's what this solves, and here's who it solves it for, and, you know, blah, blah, blah. Like, what I mean is, like, so if not so much as like, hey, I'm a customer and I'm trying to do something, but like you guys as engineers or SREs, do you guys do this for each feature that you do, that you're like, hey, this would be really nice to have it in our run book or whatever that does this?
Yeah, so you're hitting on like a key point there. So as we release features and we're launching kind of a new service, we want to have this as kind of a requirement of that feature. So, and that's even in itself like kind of a really new concept, right? Like usually feature is just, what do you want, deliver the code, and kind of call it quits. But this is incorporating more of, you know, how do we support that? How's the customer going to use that? And Hill, like you're hitting it as well as like, you know, what's the happy path in that? And, you know, how do we measure that happy path? And that's all things and components we want to introduce into user journeys and actually document and alert on and have all these things for. So yeah, we want to directly in line with, you know, releasing a new feature, and having it really though from the customer's perspective, and capturing that like end to end of what the customer's doing, what their experiences are with that new feature, and, you know, what their interactions are. So capturing all that information.
And I think the other thing is as you guys said, like, yes, with new features, like critical user journeys and a kind of a gold standard way of like defining and mapping out a feature, but it's one of the few good frameworks we have for catching up when which, considering we basically were taking, you know, hosted control planes and making the Azure Red Hat OpenShift managed service version of it to, you know, to be released sometime in the future. So, right, we have already, like, it comes bootstrapped with a bunch of features and functionality and paths that can be executed. This is one of the few industry frameworks that actually works well for catching up to something of that scale that already has so much built into it, and figuring out where to measure. And a lot of what we're doing, correct me if I'm wrong, Clement, a lot of what we're doing right now is just simply because of that's our situation. We're using this to catch ourselves up, because we have to bootstrap the service and the observability kind of like running at the same time.
Yeah, there's many aspects to that. So AirHCP is such a large service and it spans so many components and so many upstream teams and you name it, that we really have to focus on what matters and what's providing value. And you know, it's kind of this, and it's kind of the next slide that we're going into. It's a bit of a tug of war. Let's actually go to it. So yeah, it's a tug of war. So if we just solely alert on components, and that's what's on the right side of this graph. So we have SREs on one side, and traditionally speaking, we have like component concerns, right? Like our pods down, our nodes down, our cluster operators down. Is the front end down? We're more concerned about these aspects traditionally, and then on the left side, we have the customer that really doesn't care about those things. They just care if they can install a cluster and create a node pool and use these capabilities. And like you're saying in AirHCP, there's just so many things a customer can do. And there's so many features that it has that it's impossible to alert on everything right now. There's thousands of metrics that we emit. So it's kind of like this tug of war between between a customer and internal supporting teams, and OpenShift's kind of sitting in the middle. And it really, both viewpoints matter, but it's kind of like we're speaking different languages, right? Where customer, I want to install a cluster, but the supporting teams are only monitoring is a node down or is a pod down. That doesn't really reflect installing a cluster, right? Like a pod being down might not have an impact on that or anything like that. So they're really misaligned goals here. And this kind of causes friction and a little bit of like ineffective communication between like both teams or both like stakeholders here, and that flag kind of moves back and forth. So what users journeys do, and we'll do for AirHCP, is kind of bring those two viewpoints together. They'll focus the conversation. We start having different conversations because we're not just measuring on components. We start having conversations like, what really represents the user's pain, and how do we measure the user's pain, and then what prevents the user from succeeding. So those are all things that we would bake in for an individual feature and actually have documentation on. And I'll kind of go over some of those things as well in like the how. All right. So yeah, it's basically, how do we know our customer goals are successful if we're not measuring them? That's kind of like, the overall sentiment is like, we should be knowing that our customers are successful. We should be matching their kind of goals here. All right. So on the how. So this is a pretty hard thing to do. There's been a lot of conversations I've been in, and this is a real cultural shift in how we're alerting and how we're viewing a product from a technical standpoint, right? So, teams are pretty comfortable with measuring like pods and nodes and operators and those types of things. But measuring whether a customer achieved their goal can be a little bit unfamiliar and even uncomfortable. Like, how do you measure that a cluster install was successful, right? That spans many components and many different operations, and like capturing that correctly is a pretty, it's a very uncomfortable thing to do, and it's a hard thing to do.
I actually have like an anecdote on that. I have a pull request open right now to the OpenShift installer, and I had to manually verify it. And insofar as like what my changes were doing, it worked. The install still failed for something completely unrelated. And again, this is off of like, the development branch, and there's a bunch of unrefined changes in what I was working on. So like that's fair. But yeah, it was one of those things. So then it's like, okay, we're having a conversation amongst ourselves. Like, well, did the failure completely negate the testing, or because the failure happened after the code paths I introduced executed, is it safe to ignore it? And we came down to, all right, got to test it again. Because yeah, like how, you know, the user journey behind this particular feature can't be achieved. We really have to prove beyond a shadow of a doubt that the reason that didn't achieve was in fact a transient error, with our dev account running out of resources because I hit it at the most busy time, and not actually a real problem that I happened to run into that could only happen when the stars exactly align and customers could actually experience it.
Mm-hmm. Yeah, and even like OpenShift itself, it ships with a bunch of component metrics, right?
Yeah.
So monitoring that, and those are all individual things. It doesn't necessarily maybe capture, your whole experience that you're going through.
Yeah, that was the other thing, is what metrics out of the manual test. I presented a subset of them. I guessed wrong. That was one of the installer like team members who's like, obviously has like the expertise or whatever. He was like, yeah, I actually want to see these things too. And I'm like, well, I already deleted it because I was trying to make sure to like save on costs and everything. So I'll have to redo it, which is fine. But like, yeah, I guessed wrong. And if I'd had something like a critical user journey like framework around introducing new features here where we don't really have it, maybe I wouldn't have guessed wrong. There would have been a standard I could have referenced.
And you would have known, like, it failing your ultimate goal, and, are other customers or other people trying the same thing? Is that failing?
Right.
What's actually going on?
Yeah, because I don't know, like, it's when you're doing something installing a cluster, there was specific networking things that I did, and there was specific SKUs that I used, and like there's a lot of things that were, again, nothing was standardized for it, so I made decisions.
Mm-hmm.
So I don't know, did I pick just like a really weird configuration, trying to, again, I was trying to do it as cheaply as possible. So trying to do it as cheaply as possible, did I run into a configuration, or again, it was just such a transient error that it may have just been our systems not having the headroom, because I was trying to do this in the middle of the day when everybody else is doing the same thing against our very specific environment.
Yeah, and if we like capture, what a happy path is and what that, architecture looks like from a customer's perspective, even you getting help or, mitigating your problem we can decrease some time there, right? Because we have more information about what you're actually trying to do, and maybe less information about the individual component, right? So we're really viewing this from like a customer's perspective. Yeah, kind of going back to like it being hard. So yeah, you won't make everyone happy with user journeys. Even if you have like the best intent. So, customers, and what I mean about that is like there's customers, product managers, SREs, there's component teams, and all these teams kind of have different goals and different priorities of, what they deem important, really. And, not one solution is really going to fit for the entire service. So, user journeys are part of the monitoring stack, but they're not the complete monitoring stack as well. Like, still recommending to monitor on components and stuff, but user journeys kind of complement component monitoring, and they kind of work hand in hand, right? So you're capturing, is a user journey successful? Did they reach their goals? As well as individual components that might fail along the way. So having a complete stack is kind of the best recommended path forward. And that's what we're practicing as well. So you kind of touched on this as well. So how do we discover user journeys? And for Error HCP specifically, this was kind of a hard question when we first started. And just because there's so much to it, right? There's so many upstream teams, there's so many components. We're working with, OpenShift, we have Error HCP, we have Azure that we're working with, all these different kind of levels, right, and interactions. So how do we know, and where do we start, right? So we start with the evidence we kind of already have. So public documentation, that's a start of a user journey, right? Like there's public documentation on creating a cluster or spinning up node pools, those types of things. APIs and CLIs and portal operations, that's all stuff that a user will interact with to meet their goals. So all part of kind of the story that we want to tell here. And then things like, doing analytics on support cases, incidents, and SLAs. What are some things, and this kind of helps set priority too. So what do customers see? What are they trying to do? Maybe we need a user journey for that. So we're kind of gathering a list here, and I even have features in here. So, features being a user journey, that's something that we should be keying off of and actually baking into like our development processes, right? And then customer conversations, just talking with customers, maybe they're frustrated or not able to do something, or maybe something's working fantastic, right? So just kind of getting this, on the grounds kind of feedback is extremely helpful. So once you do have a list of user journeys, how do you kind of like prioritize them? Like what comes first? What does that look like? And they kind of fall into 3 categories. And there's essential user journeys, there's common user journeys, and then there's critical user journeys. So what I mean by this is essential user journeys is something that like delivers core value to the service. So something like installing a cluster, again, going back to that, like that's the first step of a user journey that a user would experience with, a product. And then a common user journey. So what I mean by that is something that's performed frequently or has or may impact like many customers. So a common user journey would be just like logging into your cluster, like is authentication working, those types of things. And then a critical user journey is essentially a common user journey and an essential user journey. So maybe something like, is CAS available? Is Kube API server up and running? That's essential to, deploying workloads or doing anything on the server. And it's also common because it's, every interaction kind of goes through that. So this helps kind of set the tone of maybe what you would want to prioritize first and measure first. But this doesn't necessarily mean how you would set your severity on like an alert severity or something like that, or a threshold. A severity should kind of come from customer impact and your SLAs. So another example of that for severity, which actually happens to be a critical user journey, is like CAS. So that's a high severity. We have an SLA around it. And it's also a critical user journey because it's essential and common.
So I know that CAS is KAS, and I know what CAS stands for, but would you go ahead and define that for the audience who hasn't seen it?
Yeah, Kube API server.
Cool.
Yeah, so all interactions kind of go through that to like deploy workloads or connect to it or anything like that. All right, so getting a little bit deeper into the how, and we kind of touched a lot on, we touched on a few of these points here. And when you're setting up like a user journey, it's good to have like a high level documentation, and that kind of puts everything together. So in that documentation, you would define the user journey, so what outcomes the customer values, what are their goals of that journey. So, I want to install a cluster, for example. And then within that, we talked about, the architecture. So you want to have like what your happy path is for that user journey. So installing a cluster, what components is it going through? What APIs are going through? What's the expected results? Sequence diagrams are usually a pretty good thing here. So it's like, front end goes to the back end, receives 200, goes to, whatever does your deployment, those types of things. So it's kind of yeah. And then another thing that you want is SLIs and SLOs and SLAs. So we talked a little bit about these, but this is how we measure and how we meet the quality bar for our customers. So this is how we measure, cluster installs are successful. And this is kind of what level we want to meet the SLI at. So that's our SLO. So what quality bar do we want to provide our customer? And then an SLA is more like a guarantee. So, we're guaranteeing for our customers, and this is our SLA, is that we have 99.95% uptime over 30 days. So that's a guarantee to our customer. I'll go over these a little bit more as well, because they're kind of important on the alerting, which I'll go over as well. I have kind of an example of how we're doing our alerting. And you could kind of see how complex this thing gets.
I was gonna say I had a really easy SLI versus SLO and a, like alert bar example for you. Let's see if you agree with it. This came up in something I was working on earlier in the week. So an SLI would be like, how many times on average does this operation retry before it's successful? So one of the things I was working on, I saw that there is like, there can be a race condition with, control plane nodes when they're starting up where they both try to get the same port from the load balancer at the same time. And so one of them is successful. The other one's like, nope, that's not available. And so like it has to retry. Now, obviously, that has a finite number of retries. Like we're going to see that it's realistically going to retry a maximum of 3 times or a maximum of 2 times because there's only 3 nodes. Mm-hmm. But that same type of retry, right? You could, if there was like, auto scaling of worker nodes, right? Then you might see a similar type of race condition where they're trying to, attach at the same port to the load balancer at the same time. You might have a higher number of retries based on what the scaling behavior is. That is something that is an indicator. It's a piece of metric. It's a metric data that is potentially useful that you probably want to capture and even maybe trend, because if there's like peaks and valleys around that can tell you information about, okay, like what's happening at that time where there's this big, peak or this big valley, right? But it doesn't necessarily like warrant an alert. Mm-hmm. It shouldn't warrant an alert. But what would warrant an alert is if the node can never become ready. And then you would say, okay, I this node never became ready. So that's my like alert with like we missed our SLO on, node becomes ready in 15 minutes or whatever. Like, and that's like an objective. By the way, I'm pulling these numbers out of nowhere. They're completely not real. Like nobody quote me on these numbers, or this is an SLO. Like this is in purely for like theoretical demonstration purposes. This is not an actual way that we measure things. We do measure node like readiness and so forth, but like not the way I am describing it. When you have that SLO, like, and you're not meeting your SLO, or you're burning your error budget, which I'm sure Simon will explain the error budget a little bit more thoroughly in a bit here. When the alert fires, you get the alert details, and then you also frequently have addition, like that's where you bring in SLIs. The SLIs may or may not have contributed to the calculation that resulted in the alert firing, but it is information or data that we know when combined with this SLO-based alert becomes information that could potentially bring you to the root cause much more quickly. So that's always the biggest thing with an SLO. An indicator is just an event that may or may not be particularly relevant, but gets associated to the objective through either directly resulting in the alert ultimately firing or supplementing that alert so that you have an idea of, you have that bigger picture of what was going on at the time of the alert.
Yeah, so your SLIs are your measurement and what you want to measure, and that could be many different things. So maybe you're measuring like the CAS availability and its uptime, and you kind of represent that over like successful signals over total valid signals, and that gives you like a happy good number. So that would be like, our CAS is 99.95% successful, or and then there's the inverse of that, which is a failure rate, which I'll get into as well. Your SLO is that's your objective for your SLI. So your SLO is something that you want your SLI to meet, and if it's not meeting, you can start making informed decisions on why it's not meeting it. So you can, maybe that is more priority with your internal teams, or maybe there's more visibility when you're not meeting your SLO. Maybe you have to call more engineers into that and kind of work towards that. So yeah, I do have other slides on kind of going into SLIs a little bit more. And for our user journeys, we're capturing like some key SLIs that we want. So we want, and this is kind of straight out of the Google SRE book. So to kind of, in order to like capture the customer's pain and their experiences, these are the golden signals to do that. So we want to capture error rates, which is like how often did this journey fail? Like what percentage of cluster installs have failed? We want to catch the latency, which you talked about too, Hill. Is that like how long are like cluster installs taking, right? Getting that measurement there. And then traffic. So, how many cluster installs are happening at one time? And then saturation. So how many, like based off the traffic, how saturated is our backend nodes? Like how much CPU are they using? How much memory, disk IO, those types of things. And then availability is also commonly measured as an SLI, but it's not included as a golden signal. But it's kind of a nice to have to see, is the service up and running or not? If it's not up and running, you might have some issues.
With everything being microservice driven anymore, I think it's, it basically a golden signal.
Mm-hmm. Yeah. We're including it in ours. It makes me sleep better at night, that's for sure.
Yes, 100% agree.
Going just back a bit too of what you want in documentation. So yeah, you want your SLIs, SLOs. We'll go into SLOs a little bit more too, and SLAs. You also want alerting. So what are you actually alerting on? That's kind of those golden signals I talked about. I'll go over an example of one as well. And then you want a troubleshooting guide. So what can prevent customer success? We kind of talked about that. So capturing those things in this guide and then writing actionable steps to it. This is something that we use, in operations. So our alerts point to our higher level documentation and our troubleshooting guides. So we use these directly to be able to like solve problems, triage, get a better understanding of, what impact does the user have? What goals aren't being met and kind of what's involved with that, right? Another thing too that we have is that dashboarding. So you touched on it, that like in an environment, there's metrics and there's a lot of metrics. So those metrics aren't always SLIs, but maybe you want to graph those metrics. Maybe they have some relation to it, right? Or maybe it's like a component metric that you want to graph alongside your user journey SLIs. So that's another thing to kind of have within this document, and whatever dashboarding system that you might have. And another good thing to have within user journeys is basically an escalation procedure. Things break, and we have a lot of upstream teams, and what escalation goes where, and how do we do that? So this is kind of putting everything together. It's putting on together what the user journeys are, what they look like, what's happy paths, what our alerting looks like, what our dashboarding, how to fix it, and then how to improve on it. So having a feedback loop there on like, how do we iterate over this document? How do we iterate over our user journeys, improve it as we go?
Yeah, I want to just briefly address the audience question, because the question was like, are we seeing a lot of OpenShift on bare metal or more so in the cloud? I mean, Simon and I very specifically work on a cloud-based team. So everything we see is typically 100% in the cloud. But like overall, the promise of OpenShift is that it's agnostic. So another trend that we do see quite often is multiple environments. So people will have multiple OpenShift clusters on-prem running on server racks, plus they'll have a cloud, and like one will be the primary and the other will be the failover. We have, so many, we have customers where they're doing different things with, they may be using OpenShift as their unified stack, but like this thing over here is done in Azure because of like the value out of Azure. This thing over here is done in AWS because of the value out of AWS. And this thing over here is done on-prem because of like whatever data sovereignty requirements are around that as well. So like we don't, what I would say we don't see a lot of is customers that are necessarily committed to only one utilization of OpenShift. we see customers that are using it across, like taking it up on the promise that, you know, that it makes of just put me anywhere and I work great.
Yeah, just to add on to that too, like there's like everything that Hilliary said is absolutely right, but like there has been an uptick lately, I'd say, on the bare metal bit, just with OpenShift virtualization and like the whole thou shalt not be named company that did their thing with their, you know, their licensing. And so like it really put OpenShift virtualization at the forefront of a lot of these virtualization conversations, which require bare metal or, you know, a virtualization capability. So yeah, I mean, like it's a mix. And now even the providers are starting to offer, I think, correct me if I'm wrong, I think Rosa offers like a virtualization service out with their managed service. I think ARO is going to do it.
We have been doing
maybe
it.
they're already doing it. Yeah.
Yeah, we've been doing it. Yeah, we have virtualization in Arrow, so OpenShift Virt can run on bare metal. It can also run on certain instances, a lot of them actually, of Azure VMs. There's usually like additional networking capabilities that those VM instances have that make it like as performant as need be. Technically speaking, Azure, I don't know if they do have or will have or kind of have. The cloud providers are starting to provide bare metal VM SKU types or instance SKU types to be used for things like OpenShift virtualization and virtualization in the cloud. We see an ask for that, and I don't know if we see a utilization of it yet. I couldn't honestly say because I don't go looking at what our customers are doing very, very intentionally. We don't go look at what customers do with Arrow. We just take care of our little realm of responsibility and pretend like we don't know anything over there because we don't want to know anything. We're the see, speak, hear no evil people on that front. So yeah, we do see an uptick in it for sure. But like, you know, it's not necessarily like it'll peaks and valleys, and one thing's popular for this reason and then this other thing's popular for this other reason. I think it all eventually somewhat normalizes.
Yeah. And chat, hopefully that answered your question. If not, feel free to ask more follow-on questions. We'll do our best to address them. But yeah, hopefully that answered it.
Yeah, but we're gonna let Simon kind of speed run this last 15 minutes because I know he has all the impressive math for us.
Yeah, thanks. So yeah, SLIs, we kind of went over that. So it's basically, you know, a measurement in percent, or it's a measure. What did we measure is essentially what an SLI is. And we have our golden signals there. SLO, so this is like the objective we're trying to reach. This defines the target we want the SLI to meet. What reliability are we aiming for? Are kind of questions we ask. What's our goal? Is there constraints like not having HA, or, you know, are we on-prem, or those types of things that might affect what our SLO is. So in managed OpenShift, we kind of agree upon those things across, you know, different stakeholders. So like BU, PM, support, those types of people. We try to come to of like, what do we want to achieve and what quality do we want to give our customers? And our SLO also, like I mentioned, helps us make informed reliability decisions. It tells us when we're doing something good. So yeah, we have 100% success rate somewhere or something like that. But when it dips to like maybe 80% success rate for cluster installs or something like that, it tells us when we need to kind of address that issue and go look at it and go fix something. Maybe there was a regression there or something like that. So yeah, an example would be like 99.95% of Cube API server availability should be successful over a 30-day window. So we have what our value is, which is 99.5, and then we have a window essentially for our SLO. Service level agreement, it's pretty simple. It's just, you know, our formal commitment to customers. So what level of service do we guarantee? What have we formally promised to the customers is the things that we're talking about in an SLA. And then alerting. So you touched on this, Hill. Alerting on user journeys. So I have an example here, and I'll go a little bit into the math, but essentially it all starts at the goal. So the goal here in this example is an SRE needs the HCP Kube API server to remain available so customers can operate their clusters. So that's, a critical user journey here. It's both essential and it's both common. The SLI tells us what to measure. We divide successful CAS availability checks by all valid checks. And you could that gives us a percentage. So the result in our success percent or the result is our success percent or the good value. Again, like we're 100% successful on our CAS. And then another value that we actually alert on, which I'll talk about a little bit more, is the failure rate. So you subtract the total, which is 100%, by the SLI. So if your SLI is at 95%, if you do that math and subtract, you're at a 5% failure rate. So, and that's exactly what we'll alert on. But I'll go over a few other concepts before we get to that. Our SLO also comes into play on our alerting. So our SLO says that it's 99.95 of CAS availability checks should succeed over a rolling 30-day window. That's the agreed upon level of reliability we want to achieve. And what that means is that it gives us an error budget of 0.05 over 30 days. And that actually equates to 21.6 minutes of complete downtime. And that's kind of important when we're dealing with this calculation. The error budget tells us how much failure the journey can tolerate before we miss kind of our reliability goal and before we miss our SLO. So for this particular CAS user journey, we're only allowed 21.6 minutes of downtime. There's another abstraction. So you don't want to actually alert on this value either. You want to alert on what's called a burn rate. So your burn rate is how quick you're consuming your error budget. So how quick you're consuming that 21.6 minutes. If your burn rate is below 1 times, then you're consuming less than your budget allows, which is a good, healthy thing. Like that's the goal, right? If your burn rate is 1 times, you're consuming exactly the amount that your SLO allows. So you'd be burning 21.6 minutes in your 30-day window. If you're consuming 14.4, it means you're consuming 14.4 times faster than you originally planned. So that's usually a problem. And that's, maybe you're burning, with CAS, like if you're burning 14.4, then, something needs to be addressed. And why 14.4? It's kind of an obscure number, but it's basically 2% of your monthly error budget rate. And you could see the calculation there. But what really matters is that this rate is fast enough to kind of deserve our attention, to we have to action on this.
And I think it really, for this particular SLO that we're talking about, the volume of API interactions that get measured to get to these calculations, and 2% are that volume. It's not like there's maybe one CAS thing in an hour, right? I don't even know how many. It's definitely in the tens of thousands. Do you actually know how many? I know it depends on cluster size and cluster activity and all this other stuff, but just blatant empty cluster runtime, do you know how much it actually is?
So you could emit a metric a second, and that's its own individual time series, and that's for one cluster, and that can span thousands of clusters. So
these are big numbers. When Simon said earlier in the day big data, this data set is huge, and that is why these percentages, it actually represents a really large number of individual failures if you counted them, while the percentages look quite small.
Yeah, it's millions of entries and millions of metrics a day. It adds up really quick. And we're kind of taking this angle to be able to scale that, because you can check each metric individually. You have to scale how you're observing your entire service. Another abstraction that we'll use as well. So this is a failure threshold, another concept here. Your failure rate and your failure threshold, this is actually what you set your alert on. So to be able to get that, we convert the burn rate into a failure threshold. Our error budget is 0.05, and we multiply that by 14.4, which gives us a failure threshold of 0.72. So we're taking our error budget by our burn rate, and we get this value of 0.72. So what that 0.72 means is if more than 0.72 valid observations fail, we'll alarm on that. And I'll kind of get into what the logic looks of that. That 0.7, we also plot this over windows for our alerting, which is my next slide here. But 0.72 in a 1 hour window is equivalent of 25.9 seconds of downtime. In a 5 minute window, it's equivalent of 2.2 seconds. And I'll kind of go over a little bit more of what that actually means in terms of our alerting. But it's a very short period of time.
This is one of the best representations of this I've ever seen. I just want to call that out.
Well, thanks. Appreciate that. It's user journeys are like a simple concept, right? Like it's customer meeting a goal, a user meeting a goal, these types of conversations. But it's incredibly complicated once you start getting into like the lower level details and what actually goes on. Even to get to this position, like you need an SLI, you need to be able to measure something that represents what you want to measure. So represents that user's goal, right? So it's a very complicated subject. It's very hard. That's why, having it within a feature and during that development time is key to have, right? If you don't
do observability driven development. Yeah,
exactly. And if you don't have that, like on retrospect, if you try to like bake it in after, it's twice as hard. So,
and this is also why the Kube API serve availability is probably our favorite example when we talk about these things. It is the easiest one, and they're all hard, but this is
exactly
still the
easiest one. I chose this on purpose.
Yeah, this is the easy one, folks.
Yeah, entirely. And don't be afraid. Like if this goes over, like if you have no idea what I'm talking about, that's totally fine. Like starting somewhere, right? And maybe researching this a little bit more and investigating yourself and how it applies to your service. Like that's the next steps, right? But this is kind of like a guide and a speed run of a lot of data in a short amount of time. Okay, so we have this this threshold, this failure threshold. And I mentioned windows. So a short window kind of allows us to resolve, or let's just go to the multi-window page. So we plot the values I went over in a multi-window, multi-burn rate context as well. So what that means is that, let's just take the first example of fast. So within a 1 hour window, a 1 hour and a 5 hour, or a 1 hour and a 5 minute window, both the burn rate or both the failure rate and the failure threshold have to meet true. So we're evaluating both windows. We're evaluating our failure threshold, so the bad requests, the failure rate, which is our bad requests, and we're evaluating our failure threshold, which is ultimately set off of our SLO. We do multi-window to catch different symptoms. So the fast catches acute symptoms. So something's down and you immediately need to be paged right away. You have to know. And you'll know within, 25 seconds for a 1 hour window and 2 seconds for a 5 minute window. So incredibly fast alerting. A medium window. So that's a little bit slower. It's for slower degradation. Maybe something's flapping. Maybe something isn't working quite as right. And in that period, it hits those thresholds and alerts. And then a slow window catches like persistent problems that will consume your entire monthly SLO budget. So something that we want to know about and maybe alert on. Maybe there's some like longer term planning that we have to do there. I know this is confusing, and this is probably even more confusing, but putting this all together. So we talked about the user journey, which is CAS availability. We talked about the SLI, which that's our measurement. We talked about our failure rate, which is 100 minus our measurement, our SLI. We talked about our SLO window of 30 days or 720 hours. We talked about our SLO target, which is 99.95% availability. We talked about our error budget, which is the inverse of that, and 21.6 minutes of downtime. We talked about our fast burn rate, so 14.4, and that's roughly 2% of our budget consumed in an hour. And then we talked about that translating into our failure threshold of 0.72. And those are all based off of our long window and our short window. So you can see how complex this is, how much is involved in alerting. And then we have this statement below. And this is kind of like pseudocode of what our alerting actually looks like. So if our failure rate, which is our bad requests in a long window, are greater than our failure threshold, and if our failure rate of our short window is greater than our failure threshold, then do whatever action. And I have an example here. So our failure rate of 1 hour is 1%. That's greater than 0.72. And our failure rate in a 5-minute window is 2, which is greater than 0.72. Then we fire an alert. If any one of these conditions aren't true, the alert doesn't fire. So let's just say it was, let's say our 1 hour failure rate's firing, but our short 2-second rate isn't firing. Then that would either resolve an alert that's already firing or fire an alert that hasn't yet. And this is incredibly powerful when you're dealing with like huge distributed systems with many clusters and all these things, is because first off, we could, acutely fire on something within seconds, 26 seconds, I think it was. And we can also resolve the alert within about 2 seconds. So you want to know when you fix the problem, right? You don't want to be waiting on some kind of monitor to update and resolve, and that takes an hour because you're sitting kind of on a call and waiting for those types of things. So it's sophisticated. It helps prevent things like false positives, which are a really important thing to kind of do in our environment. Just because there's so many clusters and so many things we kind of alert on. So yeah, that's about it for what I wanted to go over.
It was perfectly on time. Very nicely done.
Yeah, awesome.
This still is one of the most I've seen this topic on alerting and SLOs and SLIs and error budgets and burn rates and so forth presented on and talked about a lot of times. This is still probably one of the best representations I've ever seen. I could be biased because I do already understand it. Jonny, am I wrong here?
No, this is really good. This is some like deep nerd stuff. I'm sitting here like trying to carry the 2 divide by 7, power of 3. I'm like, what's happening?
Exactly. You got it.
Yeah, exactly. It's fine. It's the math is almost laughably simple. The logic to determine the math, so hard.
Yeah, that's nailing it right on the head. There's so many things involved just to get to this simple alert and all of those constructs. And it's a lot to train, for everyone on a team to kind of know this and develop against it. It's a huge effort. And that's why I started with the how. This is hard. This is not easy. And it's very challenging.
I think you've done a good job of it's never as easy as it sounds, right? Like it's because there's always the like, oh, this is going to take a minute to fix. Okay, like the actual thing might take a minute, but everything that leads up to it, like all of the, the when you slap the water and the ripple effect of everything else, right? That's what makes it difficult. So it's like it's cool to have tangible data that you can look at and be like, this is why this little statement here isn't as easy as it is. That's why it's easy on the surface, but when you actually peel the layers back, it's quite complex.
And it gives us different perspectives too, though, right? It gives us like reasoning, and we're seeing a good value, and we're seeing like, our SLO, like we're seeing what we want to measure things to, and we're seeing our SLI, reach that. And those are all kind of good conversations to have. Of like, it tells us when we're doing a good job, we're meeting our SLO. So every engineer like bonuses, right? Or whatever it might be. I wish it worked that way, but it, it tells a good story. And maybe like comparing it to a component just, and how simple those things are, is a component just tells when it's down, and that's it. But once we start adding this complexity within a user journey and alerting of this type, it tells a whole different story, and we get more information.
And a lot of times this can preempt the component being down, right? I think with like the CAS, this is such an easy example, because you're going to start seeing CAS issues when things like etcd is overfull, right? So, you can measure, etcd health and everything else like that. But sometimes the reason etcd gets overfull is it just suddenly goes, whoop, something went off the rails and spawned a million pods. And now etcd's out of headroom, and the garbage collection process hasn't kicked in yet. And, but you're going to start catching that is happening because you're measuring the CAS so closely, because that's the first thing that's going to be symptomatic. etcd will just not be symptomatic until it falls over pretty well. It's not the best thing to measure to understand health. It has, you can measure things like rate and everything, but like, I'd rather just measure CAS very, 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 very precisely, because that's going to tell me more. But then I can also have, like we said, like those SLIs, like, if I'm getting a CAS alert, let me also supplement that alert with like what's going on statistics with etcd right now, so that I can either rule it in or out very quickly in my like tree of decisions I have to make to figure out how I'm going to approach fixing this problem. So anyhow, but we are over time now, which is okay, because this is not that serious. The timelines are what we want them to be, but Jonny is in England. It's getting late for him. I do want to let him get out of here. Simon, thank you for coming on and talking about this and presenting this. Again, I cannot overstate that this is one of the best breakdowns of this that I have seen. So really, really well done there. I don't know what our next episode will be. Jonny and I still have to figure that out. But when we do, we'll post it on LinkedIn day of, as per usual, because we're super great, very on top of it podcast hosts. Yes. But yeah, until then, just going to remind everybody to choose your technical debt very wisely, and we'll see you soon.